All right, so here's the assignment portions of Nitro 4.3. In 4.3.6, they need us to ask the user for three things, but they don't even have the scanner in here yet. So I'm going to come over here to Docs, search for scanner, and copy and paste that. Okay, so scanner my input equals new scanner system.in system.out.print line, and they want us to say enter your word. And so then we're going to say string the word equals my input dot next line. Okay, and then enter the letter you want to replace. Sorry, that should have gone up here. Enter the letter you want to replace. Letter to replace. And then enter the replacing letter. And I'm going to call that one letter to replace with. So the letter that we are to replace and the letter that we're going to replace that with. And then they want us to call replace letter and give replace letter all three of those things we just got from the user. The word, the letter to replace, and the letter to replace with. And I think I don't want to just call that. I think I want to do system.out.print the return of that. Okay, so this is all assuming that we have a working method called replace letter. And first of all, notice that in the replace letter method, they're only asking for two strings, but they're telling us here that they want us to do another string. So we're going to say string letter. I'm going to call this one letter I'm going to call this letter to replace with. And I just decided I'm going to change my guys up here. I'm going to call this one letter getting replaced. And I'm going to call this one letter doing replacing. So letter getting replaced. I just realized I was using the same variables they were using, and I don't want to do that. When I say they, I mean in their method. So I'm getting the word, the letter getting replaced, and the letter doing the replacing. The word, the letter getting replaced, and the letter doing the replacing. So when this method gets a word and a letter to replace and a letter to replace with, it does this. Now, right now, all it is set up to do is to return an int, which counts the number of times we find letter to replace in there. So, for example, if I run right now, assuming that it runs correctly, it's just going to count the occurrence of a certain letter in a certain word. So if my word is hello, and the letter we're replacing is the L, it's just going to tell me that there's two L's. And if I do the letter hello, and I look for an E, and it's going to tell me there's only one E. And if I do the letter hello, and do the letter Z, it's going to tell me there's no Z's. So it's not really working the way as intended right now. So first of all, we need this to return a string. And I'm just going to return the same word that they gave us. And then, but we're going to obviously modify that word. So we don't need this integer for count anymore. So if we find a letter to replace, we're going to do something similar to what they did on the video. We're going to do a string for the front, a string for the back, and then we're going to change the variable word. We're going to change the string word to be the front plus the letter doing the replacing and the back. So we're going to use some string methods here. This is going to be the word dot substring starting at 0 and going up to I, but not including I. And then the back is going to be the substring starting at I plus 1 with no end argument. So, for example, if we give it the word terrible and we say that the E gets replaced with Z, then the first time through the loop, I is 0. Okay, the word dot substring, at I, comma, I plus 1 is the word dot substring at 0, comma 1, which gives us the very first letter, which is a T. That does not equal my letter to replace, which is the letter E. So therefore this code does not happen, and we go to the next value of I in the loop. So now I is 1, and we say the substring from I to I plus 1, which will now be the substring from 1 to 2, which will be the letter E. So now this matches our replacing letter, or the letter to replace, so that equals the letter to replace. So now the variable called front is word.substring 0 to I. So that's word.substring 0 to 1, which is just going to give us the first letter, which is T. The variable called back is going to be word.substring I plus 1. So that's word.substring 1 plus 1. So that's word.substring 2. So starting at the second character, character 0, character 1, character 2, which is the first R, starting at that R, the rest of the word. And then when we say front plus letter to replace with plus back, that's going to be the front, which is the letter T, plus the letter to replace with, which is the letter Z, plus the back, which is this. So it's going to be the word terrible, but with the Z in place of the E. I think that's going to work correctly if I've got all of these indices done correctly. So let's see. See if this runs without an error, first of all. Okay. I want to replace the E with a Z. That looks good. Okay, let's try this again. I want to replace the R with a 0. Okay, that looks good. I want to replace the I with a 4. Okay, that looks good. I want to replace the Z with a 0. And there is no Z, so it does nothing. I think that's working the way we need it to work. So on to 4.3.7, which is about passwords. So 4.3.7 is about passwords. So write a method called password check, which is already here, to return if the string is a valid password. The method should have the signature shown in the starter code. Password must be at least 8 characters long. So the first thing I want to say is, if the password they're giving me dot length is less than 8, then we should return false. Okay. Now again, this says prompt the user to enter a password. So we need our import utility. Bring this over here and bring this up here. Okay, I like calling my scanner my input. Okay. So we're going to ask the user for some password. System.out.print line. Okay, they don't have anything there. So I'm just going to say enter your password. And then we're going to do system.out.println password check giving their, sorry, I need to get their password first, string the password equals my input dot next line, and then password check using the password, which should print true or false. So for right now, I'm going to return true unless the length of the password is less than 8. So we're going to ask the user for a password. I'm entering anything, and it says true. That's a valid password because so far I'm only checking the length is 8. So if I make my password 1, 2, 3, 4, 5, 6, 7, that length is not more at least 8, so it's going to say false. But if I make my password 1, 2, 3, 4, 5, 6, 7, 8, then we've got 8 characters. So far, so good. Now, we got to check a lot more than that, though. It may only consist of letters and digits. So they're giving us a big hint here on how we can check that. So let's create a kind of long string, which is going to be called letters and numbers. I'll even put the word and in there. Letters and numbers. Okay, this is going to be a long string. Okay, and then the capital of all those and then the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that string contains all letters and numbers. So now if their password is at least 8 characters, now we want to do a for loop. So for int I equals 0, I less than the password length, and I plus plus. So for every character in their password, we want to see if that character is in this list. Okay, so let's say something like this. String this letter equals the password dot substring at I comma I plus 1. And just to see this at work, we're gonna for temporarily we're gonna do system.out.println this letter, and then we're gonna say if letters and numbers index of this letter is greater than is less than 0, then return false. So let me explain this. Index of tells us where you can find this string within this string. So if we do index of the letter Z, it will look in letters and numbers, and it'll find where the Z is, and it will tell us that Z is at position 25, which will be greater than 0, and so this line of code will not execute. But if it does not find this string within this string, then the index of returns an index of -1. Which is technically an illegal location within the string, but that's its way of indicating that that was not found. So if this particular letter is found within here, then we're okay. Otherwise, we have an invalid password. So just to spruce this up a little bit, system.out.println this letter is not a number or a letter. Okay. Otherwise, let's do this. This letter is a number or a letter. And I'm only doing this just so we can see this whole thing at work. I'm going to have to get rid of that for us to pass the test. So what does it not like? System.out.println this letter. This, I need to capitalize the word letter. It did not recognize that variable. Enter your password. So let's say I enter the password YouTube. Okay, so YouTube is not at least 8 characters, so that already is false. It's not a valid password. Okay, so let's enter password Microsoft. So it looked at the M. M is a number or a letter. It looked at the I. I is a number or a letter. Every letter in the word Microsoft was checked, and it was found to be either a number or a letter. And so therefore, this function returned true, or I should say, yeah, this method returned true because we went all the way through the string and we never got to this line here. So here's another example. J M hyphen 5 37. J is a number or a letter, A is a number or a letter, Y is a number or a letter, M is a number or a letter. It gets to the hyphen and it says hyphen is not a number or a letter. So remember, it's looking for the capital M within this string. It found it. It would be looking for the 5 if we had gotten that far. It would be looking for the 5 within that string and it would find it. But it's looking for the hyphen within the string and it doesn't find it. So it knows that hyphen is not a number or a letter and it returns false. So I think this is exactly what they want us to do here. The only thing I need to change now is I'm not going to print out the letter every time. I'm not going to print out that message and I'm not going to print out that message. I just want to return true or false. Either it's a good password or it's not. I should say a valid password or it's not. Bill Gates 47. That's fine. But if we do Bill Gates equals 47, it's false because it's got a character in there that's not a letter or a number. So I think that's doing what we needed to do if we just needed to return true or false. So that's it for 437, and now we're on to 438, which is about palindromes. Okay, so here we're going to create two methods actually to determine if a word is a palindrome. First of all, we're going to get some input from the user. Scanner my input equals new scanner system.in and system.out.println. Type in your text. And then if is, string the text equals my input dot next line, and then if is palindrome the text. If the text is palindrome, then we're going to print your word is a palindrome! Exclamation. Otherwise, we're going to print something about it not being a palindrome. Not a palindrome, and instead of the exclamation mark, a frowning face. Not a palindrome. So, the is palindrome has not been defined yet. They've created the signature for is palindrome, but that hasn't been created yet. And then we need a reverse string. So we saw reverse string a little bit earlier. But here's what I would like to do to reverse a string of text. So they're giving us something called text. For int I equals 0, I less than text dot length, and then I plus plus, and we're going to create a new string that I'm going to call the reverse, and it's going to start off to be an empty string. And what we're going to do is we're going to take the reverse. Well, let's do this. Let's say string this letter equals text.substring from I to I plus 1. So we've done that before. So we're picking off one letter from the string. And then we're going to take that letter and we're going to add it to the reverse string. And then we're going to store that as the reverse. And then when we're done going through that loop, we are going to return the reverse. So if I go back up here and just test that out, for right now for Palindrome, let's just say return false, just so our code will run without error. But what I really want to do is this. After we get their text, let's do system.out.println their text, and then let's do system.out.println reverse of the text. So let's see if that little piece works. So if I type in J, it regurgitates J and it types it backwards. And it's always going to say not a palindrome because I have this returning false always for right now. Okay, so let's do something else like race car. And it reversed it, and reversed it is race car still, but it says not a palindrome because we haven't done this yet. So here's what we need to do in this method is palindrome. They're giving us text. Is that text equal to the reverse of that text? It would be really cool if I could say that with an equal sign, but because they're strings, I have to use the dot equals method. Is the text equal to the reverse of the text? So this right here will run this method and reverse the text, and then we're seeing if the original text is equal to the reverse of the text. If it is, then we return true. Otherwise, we return false. So let's try that again with the word race car. The word is a palindrome. But if I type in the word J, it can reverse the word J, but J is not a palindrome. So I think that's working. Oh, let's try one more just for jollies since we're on CodeHS. There's Carol backwards, not a palindrome. So I need to get rid of these two lines where it printed the word and it printed the word reversed. We don't need, that was just for me to check what I was doing, but we don't need that anymore. So if I type in Carol, it says not a palindrome. So they want us to do madam and hello. And so if I do madam, it's a palindrome. If I do hello, it's not a palindrome. So I think we're okay there. Before we go on, I just wanted to show one way that we could streamline a little bit of this text. When we say if the text equals the reverse text, then return true, otherwise return false. We can actually do all of that in one line, because this statement right here, text dot equals reverse text, that statement right there is either true or false. So all I really have to do is return that. Text dot equals reverse text. That's either true or false, and we don't even need all of this here. So let's check the code and make sure everything still works with that little twist. Oh, it's not going to run at all because I don't have a semicolon. How about that? Now check the code. So that works just as well that way. So that's 4.3.8 on Nitro. Now on 4.3.9, we're going to do fixing grammar. Okay, so first of all, they want us to ask the user to enter a sentence. And so I need all of this stuff again up here somewhere. And I'm going to call my scanner my input. And we want to say, well, it doesn't really give us an example, but we want to say system.out.println enter a sentence. And string this sentence equals my input dot next line. Okay, and then we're going to system.out.println use proper grammar on this sentence. Now, as you know, there are many different grammatical mistakes we could fix, but let's take this step by step. Right now, let's just return the text. So this should run without error. Just entering these are the times which try men's souls, and it just returns that and prints it out. So right now it's not doing anything to fix grammar. So the only thing they want us to do is replace the word to, so that is the number 2, with the word to, and return the updated text. So I'm going to make a new string called new text. Start that off to be an empty string. Okay, and then let's do a loop to go through or traverse the string that they gave us called the text. Int I equals 0, I less than the text dot length, and then I plus plus. Okay, so string this letter equals the text.substring of I, I plus 1. You've seen us use that technique before. This is giving us one letter from the string, or one character, I should say, from the string, but one letter from the string. And if this letter dot equals the number 2 in quotes, then instead of adding the number 2, we want the new text. What we want to add to new text is the word 2. So new text plus equals the word 2. But if the letter is not equal to the number 2, then we can just say new text plus equals this letter. So if the letter is a regular letter, then we're just going to add it to the string called new text. But if we find the number 2, we're going to replace it with the word 2. And then when we're all done, we're going to return something called new text. And then up here, that's going to print out. So if I say something like, go to the store, it changes it to go to the store. Back to back, changes it to back to back. So I think that's all working how we want it to work. But then they added one more little wrinkle here. So I think this is correct. But then they say the method should also print out the number of grammatical errors that were fixed. So for example, if we do this, the method should also print that we fixed 2 grammatical errors. So in our method here, let's also define an int, which we'll just call errors. And let's make that equal to 0. If we find the number 2 within the text and we have to change that to the word to, then I want to take our errors variable and add 1 to it. And so after going through that whole loop, our errors variable will have a count of how many errors we fixed. And so before we return the fixed text, we can say system.out.println fixed end quote plus errors plus quote space grammatical errors. So, for example, if I type in back to back, it says fixed 1 grammatical errors. And if I say time to go to the store, it says fixed 2 grammatical errors, time to go to the store. I think that's doing what we want it to do. I might have a space or something off in there, but I think that's what we wanted to do there. Okay, so that's 4.3.9. Now we're on to 4.3.10, Teen Talk. Oh boy, this should be fun. So I feel like this is more like 80s teen talk with the word like all over the sentence. But specifically, they want us to take a sentence and put the word like in between each of the words. Okay, so this is very similar to the assignment we just did, except on the assignment we just did, every place there was a number 2, we replaced it with the letters TO. Now we're going to put the word like, in between each word, which means every place the original phrase has a space, we're going to replace that with a space and the word like and a space. So we have to have the word like every other word literally. So this one has a class called teen. So let's see what's going on over here in the class called teen. So a teen has a first name and a last name and a grade and a Boolean for whether or not they have text messages. So this is the constructor. Teen with a first name, a last name, a grade in school, and whether they text message others and need to write text to others. The toString method is going to be the kid's name and is in grade and wants to send this text. So that's the toString method. And then here's our teen talk method. So this method should change the text message. So this is where we want to construct something very similar to how we did on the previous exercise. For int I equals 0, I less than text dot length and I plus plus, and then string this letter equals text dot substring from I to I plus 1. And then depending on what that letter is, we either add that to our string. So I'm going to call the string teen text. Make sure that's not anywhere else on the screen. Teen text. So we're going to have a string called teen text, which starts off empty. And we grab one letter from the original string. And we say this: if this letter dot equals a space, then our teen text, we want to add a space and the word like and a space. Otherwise, all we're going to do is teen text plus equals this letter. So if it's a regular letter, like the letter H, we're just going to add that to the string. If it's an E, we're just going to add that to the string. The L, we're going to add to the string. The L, we're going to add to the string. The O, we're going to add to the string. Then we get to the space, and we're going to add to the string space like space. And then we get to the W, and we're just going to add the W and continue on like that. So I think that's what we want to do. I think at the end of all that, we'll have a goofy looking string called teen text, and then we're going to say return teen text. So I think that's going to work. This we don't have to fix. Constructor, we don't have to fix any of that. Okay, so then we're coming over here to the teen tester. Create a new teen object. So they're creating a teen object and they're printing it out. So let's see what happens so far when we create a teen object and print it out. This person is in grade 10 and wants to send this text. Then ask the user to input a text message. So once again, we need the scanner object. input, and then system.out.println. Enter the text message being sent. So we want our user to enter the text message being sent. So I'm going to make a new string, this message equals my input.nextLine, and then call the TeenTalk method to translate the message to TeenTalk. So we have a teen object which is called my friend, and since that's a teen object, that has access to all the methods in the teen class, including TeenTalk. So our teen object called my friend can do TeenTalk, and we're going to do TeenTalk of this message. And what's actually going to happen there is TeenTalk is going to return the interesting message. So I don't want to just call this method TeenTalk. I want to do system.out.println. I want to print the result of that TeenTalk. So let's try this again. This person is in grade 10 and wants to send this text. Enter the text message being sent. Hello world. Hello like world. So every character it added until it got to the space, and then instead of adding the space, it added space like space. So if I say that is so funny, that like is like so like funny. If I say hello world, how are you doing? Hello like world, like how, like are, like you, like doing. I think that's doing everything we need it to do. Beautiful. So that's it for Nitro 4.3.10 on TeenTalk, and I think that's it for Nitro 4.3. Woohoo, string processing badge.